Okay, we are back again. Is back to the slope-intercept form. I really just want to finish this whole idea of slopes because you'll find that out tomorrow. It's for algebra 1 or if it's in geometry, and I told you guys that, you know, certain concept you're still missing possibly would be under the slope-intercept form. And so this is the second video for the slope-intercept form. It's going to be a little bit more difficult, but hopefully I'm going to cover why this form, slope-intercept form, is so useful in math anyway. So just a reminder, y is equal to mx plus b is your slope-intercept form. Follow from the previous video, I would actually say, you know, if your y is not like right over there in the beginning, you are going to do something about it to change that into slope-intercept form. And in this video, you're going to find out why we want to have it, because it's such a powerful, such a useful equation, and it will tell you a lot of different information about your straight line. All right, and so just in case you do not remember, slope is going to be that number sitting there in front of your x. Well, y-intercept, I do want to talk about what it means by y-intercept though. Y-intercept is your b. Okay, this number can be like a -5. If it's -5, then your y-intercept is going to be -5. Now, the intercept is a very useful point because we are talking about if I have your x and y axis. So we have your regular x and y axis. The intercept is correlated to where you can find that point on your y or x axis. So we have y axis over here, x axis over there. So let's say if I have an equation that looks like the slope-intercept form, I'm just going to randomly write one out. So y is equal to -2x plus 2 as an example. So for this scenario, your y-intercept is equal to 2. So where can we find this 2? So your 2, let's say this is 2. Your line, your straight line, is going to pass through this point every single time according to your slope-intercept form. So let's just make sure we follow what's going on. So I'm going to write another one. I'm going to use red. Y is going to be equal to 5x minus 4 as an example. So if we have this example, your y-intercept is going to be on your y-axis somewhere around -4. Let's try to make it at least proportional somewhat. So your red dot for this straight line is going to be -4. Let's talk about another case just in case. So for example, another example is y is equal to just 10x. Alright, just 10x. In this scenario, you do not have the b. When we do not have the b, we actually have to add a 0 over here. It's not there because it's a 0, and what it means by that is your y-intercept is going to be right in the center of your x and y axis. So 0 is going to be there. And y-intercept is very useful, and you'll find that out very, very soon, because when we are graphing this, normally that's where we want to start. Okay, so let's go ahead. So for example, I've been talking about, oh, we are going to graph this. We are going to graph something. So from an equation to the diagram. So what I mean by that is, it could be any random equation I can give you. So long as it's in the slope-intercept form, we should be able to graph this without too much problem. So simple one, y is equal to the slope. Let's make it a little bit more difficult. -2 over 3 maybe, x, and this time we're going to have the y-intercept. Let's just call it 2, okay, plus 2. So with this setting, my slope is going to be -2 over 3. So go back to the beginning. That's basically my rise over run. That's going to be my rise over run. and my y-intercept b is going to be equal to 2. Alright, so we are going to use this pair of information, m, y/run, and the b, to draw a diagram. Let me have all this good practice over there. When you have the x and y axis, put your x and y over there. You want to put the 0 in the middle. So that is a lovely looking graph. So I want to start with 2. 1, 2. So we are just going to say, okay, this is going to be 2. Alright, so we are going to have 1. We're not going to make it too difficult. Let's just have a very simple system. So I'm going to start with y over here, this point. Okay, that's where I'm going to start. And from this point, we have to look at our slope, the y/run. We want to find out from this point where I have to go to get to another point. Okay, if you're going to draw a straight line, you want 2 points. You don't need like 50,000 points. You just need 2 points. So we want to know that we are going to go rise is -2. So rise is -2. Normally when you think about rise, it's actually going up. But if I have a negative, I'm going to go down instead. So instead of going up 2 times, I'm going to go down 2 times. Let's change the color. Let's change the color. So I'm going down 2 times. 1, 2. Okay, so I'm staying over here, waiting, and I'm looking at my run. I have to figure out how many times I have to run. And according to the number, I have to run 3 times. 1, 2, 3. So I start with this point. I ended up with the second point right over here. Alright, so this 2 points is going to give me a very good guideline to draw a straight line. We don't need many points, we just need 2. And so, having that said, if you have your slope-intercept form, you gather your y-intercept, you use your slope, it's going to just give me enough information. Wow, this thing is really thick. Okay, so that will give me the information, and subsequently I can say that, well, this equation is correlated to this line. Normally I will actually write the equation right next to it, just, you know, make it better looking. So this equation, that straight line, is what we call -2/3x plus 2. So from any equation, if it's in the slope-intercept form, you should be able to draw this without too much problem. So long as you can find the y-intercept, so long as you understand y/run, you will be able to draw that straight line without too much problem. So that's the first bit. Why slope-intercept form is very useful. Normally, if I'm going to give you an equation, I would expect you to be able to draw it without too much problem. Now, then we have to talk about the reverse process, right? So it's not always giving you the equation. Sometimes they may give you the diagram instead and say, well, can you tell me what is that equation? So that's what we're going to do. So this is the next one. Again, I should put the x, y, and 0 in the middle. And we want to look into this scenario and talk about, I want to find the equation. So this time, the question is a little bit different. You have the diagram already. You are not drawing anything. And they want you to give them the equation. So just like the slope-intercept form, y is equal to mx plus b. Your job is to find out what is the slope and also what is the b. Okay, and the y-intercept is going to be very useful. That should be where you are going to find the number first. So in this scenario, I should be able to find the y-intercept. It should be right over here. So again, it's just 2. Simply, the b is just going to be 2. So I'm going to write that down first. So b is going to be 2. And now after this, I have to find the slope. Okay? And if you look at this diagram, or this straight line, okay, we are going to find points that are nice to use, so or at least is reasonable to look at. we can look at this straight line and we can pick many points. Any points on it will be able to give us a slope, but we may want something that is easy to use. Okay, it's very easy to use. So let's say if I'm looking at this line, I have 1 point already. I'm going to find another one. I will not. It's just a counter example. I will not do this point. Now, the reason for that is this is 1, this is 2, this is 1. This is going to be a half, right? 2 and a half as a point goal is not too bad, but I'm sure we can get something a little bit better than this. And so this is a good skill to have. I mean, you know, picking a nice point to work with. In fact, I can see some points that are really nice already. I'm going to pick this point. I think this point is fabulous, way over there, because it's ended up way on 2 integers. Okay, this is going to be -1, -2, -3, -4. This is going to be 2, 3, 4, 5. So long as we can count off this, I would say, okay, I'm going to use these 2 points. I'm going to use these 2 points. Now, after this, once we pick the point, our y-intercept is always going to be there. It's going to be a very useful point. I'm going to talk about the y's overrun, right? The y's overrun says from a point going to the other one, I want to figure out how many spots is going to go up or down. How many spots is going to go up or down? Yeah, it's not important for me. So you're going to go 1, 2, 3. Hopefully you see this process. You're actually going down 3 times, right? Going down 3 times. So the rise is not going to be a positive number. 1, 2, 3 is going to be a 3 way over there. And then from this point, I'm going to move to 2. So I'm going to go that direction. 1, 2, 3, 4. So I'm going to end it up with like a 4. Alright, that's how we find the slope. And as I said before, your job is to find out what M is and the B is, and subsequently we can convert this type of information into your slope-intercept form. So your slope-intercept form after all of this, y is going to be equal to -3/4. X is going to stay. Your B is +2. So that would be your answer for all of this. Just join another one. Alright, so I noticed that some of you cannot do it even in the geometry, that some of those questions we just did last week, they will give you the diagram and people just couldn't write down the slope-intercept form, and it's really not as difficult as you think. Should I point that out? Yeah, I should. Some people may have a different idea when they think about slope. So for example, you don't like going down this way. Let's erase off this first. I'm sorry. You may be a very different person. You don't want to go down this way. You may actually say, oh, I'm going to run over here. I'm going to go that way. The run is still going to be 4 though. The run is still going to be 1, 2, 3, 4. So when you fill up the y's overrun, the number you're filling over here is going to go for that direction, and from that direction you're going down 3 times. So it doesn't matter which way you're going to go, you're still going to get the same slope, -3/4. And I would always keep the run to go to the right. Okay, I always try to keep the rise as like positive going up, negative going down, while the run is always running to the right. Okay, so that is 2 very simple idea of how to convert your equation to a diagram, how to draw it. The other one is, if I'm giving you the diagram, how can I convert that back to the equation? So these 2 things is, you know, kind of like the reverse process of this. I was going to do the next bit, but I think I'll start the other video instead. The next one is, let's get into the math. we actually have 2 points. How are we going to get to the equation? So that will be the next video. I'm really trying to get all of this out of the way by tonight, and so there will be a lot of video coming up tonight. Okay, bye for now.